Good morning friends. Today we can see the mycelial modifications and vegetative structures in fungi. First we can see vegetative structures. Some filamentous fungi, they exhibit some vegetative structures. And these vegetative structures, they have no reproductive value. They are mainly used to differentiate clinically significant fungi, that is for differentiating medically important fungus. The main vegetative structures include spiral hyphae, nodular organ, racquet mycelium, pectinate body, favic chandeliers, peridial hyphae. First we can see spiral hyphae. Mycelium appears as a corkscrew-like turns. This is the spiral hyphae. We can see it has several turns. It is mainly observed in dermatophytes. Example, trichophyton, mendacrophytes. Second one is nodular organ. Here we can see the mycelium, it is enlarged like a nodule, and this enlargement of mycelium contains closely twisted hyphae. It is mainly seen in alter mycelium, and example is again another dermatophyte, Microsporum canis. Third one is racquet mycelium. Here the hyphae is showing regular enlargement of one end. Here it is regularly enlarged at one end. This is racquet mycelium. Next one is pectinate body. Here we can see short irregular projections or protuberances formed on one side of the hyphae, giving it an appearance of a broken comb. This is the broken comb-like appearance. It is mainly seen in dermatophytes. Next we can see favic chandeliers. These are short multiple branches appearing at one end of a hyphae, resembling a reindeer horn or a chandelier. This is resembling a reindeer horn. Example is Trichophyton violaceum. Next one is peridial hyphae. It's a wide multiseptate hyphae and it terminates in a spiral structure. Therefore, these are the main vegetative structures seen in filamentous fungi, and these vegetative structures, they are mainly used for differentiating clinically important fungus. Next we can see mycelial modifications. Mycelial modifications are exhibited by some fungus, and these fungi, they have these modifications, and these modifications have specific functions. The main modifications are sclerotium, rhizoids, apricorium, Haustorium, prosenchyma, pseudoparenchyma, stroma, and snares. First we can see sclerotium. Sclerotium, it is a thick walled resting body. Somatic hyphae get aggregated to form sclerotium. It is thick walled and it contains food reserves. It remains dormant for a long period of time and can germinate under favorable condition and produce mycelium. Example is claviceps. Second one is rhizoids. You already know about rhizoids. You have studied rhizoids in Rhizopus. These rhizoids are short root-like outgrowths of the thallus. This is the rhizoid and is formed at the base of the thallus. It is having the function of the roots. It helps in attachment, that is, it is serving as an anchoring organ. It can also function as a food absorbing organ. Apricorium. This is Aprisorium. And this Aprisorium, it is mainly seen in parasitic fungi, mainly ectoparasitic fungi. It adheres to host cell. It helps to penetrate into the host cell. It is also functioning as a resting organ. It is mainly seen in ectoparasitic fungus, example rust. Next we can see Haustoria. It's a special hyphal structure meant for nutritional absorption. It is also seen in parasitic fungi. Simple knob-like or balloon-like structure. It is similar to a miniature root system. Then the germination of spores, it produces germ tube. Then this results in the formation of Aprisorium, and this Aprisorium, it penetrates to form an infection peg or penetration peg, and this infection peg forms an infection hyphae, and this infection hyphae, it forms the Haustoria. This is the Haustoria. This Haustoria secretes certain specific enzymes, that is hydrolytic enzymes, and these hydrolytic enzymes will hydrolyze insoluble components of the host cell, mainly proteins and carbohydrates, and is converted into soluble components, and these nutrients are absorbed by the parasitic fungi without killing the host. Haustoria also provide a greater surface area for the exchange of nutrient materials. Next we can see prosenchyma. It is rather a loosely woven tissue of hyphae composed of elongated cells. This is prosenchyma. Here we can see loosely woven tissue of hyphae, and this hyphae contain loosely woven tissue, and the tissues mainly formed of elongated cells. Next one is pseudoparenchyma. In the fructification of higher fungi, we can see pseudoparenchyma. The hyphae become woven and intertwined into a compact mass. Snares. Snares are produced by predaceous fungi. This predaceous fungi can trap nematodes and protozoans. They are forming a trap-like structure. Here we can see they can form the fungal traps, and these traps get contracted, and the nematodes get entrapped in this trap or ring formed by the fungus. One example is Arthrobotrys oligospora. It's a nematophagous fungus which produce constricting rings, and these rings will trap the nematodes. Rhizomorph, it's a root-like aggregation of somatic hyphae, also called mycelial cord. It is dark brown in color. It's a rope-like coiled structure. This is rhizomorph. Has higher infection capacity, high penetration capacity, survive for many years and germinate under favorable conditions. Example is Armillaria mellae. Last one is stroma. It's a compact somatic structure. It's a cushion-like structure. Example is Taphrina maculans. It is producing stroma. That's all about the vegetative structures and mycelial modifications. Hope you all understand the session. Thank you. Have a nice day.